Okay, so yesterday we talked about acceleration. Okay? And this formula, which we had already used when we were calculating the acceleration from velocity versus time graph. Okay? But yesterday we started looking at it in terms of how do I use it for a word problem. Okay? And it tells us that acceleration is any change in velocity or the rate at which velocity changes. Okay? So in order to solve for that, we would need final velocity, initial velocity, and time. Right? So we looked at some of the manipulations of that formula yesterday, and that's kind of what we're going to work on today, is looking at word problems, being able to figure out what did I get from this problem, what am I being asked to calculate, okay, how do I manipulate the formula, et cetera, because it's going to take a little bit of practice to get used to using that formula. Okay, so let's see how much we remember. Write that one down and give it a try. Okay, in that one you are looking for the final velocity. Which is which part of this formula? Final velocity would be? VF. Okay, so you're going to do a little algebra on that one. Okay, write down your givens, manipulate the formula, plug in the numbers, solve. So, question says, what will the final velocity of the race car be? So as we established already, that means we're looking for VF. Okay? If it starts at positive 15 meters per second, what did they give me there?
Initial.
That's initial velocity. And accelerates at positive 7.2 meters per second squared. What did they give me there? They gave me the acceleration, okay? And I can tell that, from the context of the question where they said it accelerates at this rate. That's always a dead giveaway, okay? But also from the units. Okay, and then they tell me that it does that for 6.5 seconds, okay? Seconds is always a unit for time, so I know that that's t. All right, so I need to manipulate this formula so that it solves for VF. According to the rules of algebra, I should move what's not attached to VF first. T is not attached to VF. All right? So I'm going to multiply both sides by T. T will come over here. And then I want to move VI. Right now I'm subtracting VI. If I want to move it, I do
Addition.
the opposite. So I do addition. Okay? And that'll mean VI plus T times A gives me VF. All right, so that means that VF will be positive 15 plus 6.5 seconds times 7.2 meters per second squared. All right, gives me 61.8 meters per second, which is what I saw on lots of people's papers as I walked around. So that's good. Okay, that is probably the second trickiest of the manipulations of that formula. Okay. The trickiest one is for VI. So why don't we try one that has VI? Okay, we're looking for how fast a boat was traveling initially if it accelerated to positive 30 meters per second at a rate of positive 2.6 meters per second squared for 8.9 seconds. This one, okay, it's asking us how fast the boat is traveling initially, so that means we're looking for VI. Okay, it accelerates to positive 30 meters per second. That would be, our final. Okay, so that's VF, positive 30 meters per second. Okay, and it does that at a rate of positive 2.6 meters per second squared. So that's our acceleration. Okay, it doesn't outright say that's acceleration, but from the context of the question and the units, we know that that's what that is. And it does that for 8.9 seconds. Seconds are always time. All right? So I need to manipulate now for VI. Okay, so my first step would be move T, just as it was before. So moved T. Okay, T is over on the other side. Okay, now I want to solve for VI. So I could subtract VF over to the other side, but that's going to solve for negative VI, which if you're okay with that, you remember that what you get is negative and you have to make it, you have to take that into account, that's fine. I don't like doing that, okay? So I would go VI plus T times A, okay, just as I did before, okay? That solves for VF, but now I'm just gonna subtract T times A back over to the other side. And the reason I can subtract those two things, even though they're being multiplied together, is I'm not trying to separate them. Okay? If I was trying to separate A from T, then I would have to do some division. But according to order of operations, would I multiply those two numbers together before I add them to VI? That's why I can move them together. They're really just one number. Okay, it's like X, so I could subtract X over to the other side. All right, so now I've got my formula. VI equals the final velocity minus time times acceleration, or minus the change in velocity was what we said yesterday. Okay, so that's going to be then positive 30 minus 8.9 times 2.6. Okay, so the initial velocity of the boat was 6.86 meters per second, and that would be positive for that one. Okay? Okay, so now we have an example in our notes of every manipulation of that formula. We've solved for A, for T, for VI, and for VF. Okay, so now you have an example you can refer back to. We have not done any questions where there's a change in direction. Is that possible when an object is accelerating? It is, okay? If I had, let's say, as an example, a car is driving up a hill and it runs out of gas. Okay, is it gonna keep going up the hill? As soon as it runs out of gas, it's gonna start accelerating down the hill. Is it gonna move down the hill right away? No, it's going to keep going up the hill, and then it's going to start going down the hill. Okay? In that case, we have to keep in mind that acceleration and velocity are vector quantities. Okay? So I could have positives and negatives in my question, and I have to make sure I get those straight from the question, from the context of the question. So I have to read it carefully. It's back to reading comp. I know that's like a nightmare, at least a nightmare for me, but okay, if you don't like reading comp in English, this is unfortunately a little bit of reading comp, okay, that we're going to have to do. Okay. This is one where that happens. It's like I'm the guy that made these up. Okay, write this one down, give it a try. Ball is rolled up a hill at 4.5 meters per second. It accelerates down the hill at 2.1 meters per second squared. What's the velocity after 3.5 seconds? Okay, so let's have a look at this one. So context of the question is important here. Ball is rolled up a hill at 4.5 meters per second, but it's accelerating down the hill. Okay, so you got one of two things that you can do here in terms of vectors. Okay, what I have a lot of kids do is they just go, all right, here's the ball. Okay, this direction is going to be positive, and this direction is going to be negative. Okay, they just draw it out. Or they write out in their givens, they say, okay, ball is rolled up the hill, so VI is positive 4.5 meters per second. Or they write VI equals 4.5 meters per second uphill, okay? But the vectors need to be there, okay? Now, my recommendation is actually a combination of two things. This, because this is the mathematical representation of uphill and downhill, and this, because it reminds me in my answer what vectors I need to use. All right? If I switch uphill and downhill to positive and negative, which I have to do, I have to switch them back at the end. Right? I can't give a vector of positive when I was told in the question your vector is uphill. Okay? I have to always have my answers vector match what I was given in the question. All right. So VF is what we're looking for. We're looking for its velocity after 3.5 seconds. So that was a time. And they told me the acceleration was 2.1 meters per second squared downhill. Okay, so this is the formula I'm gonna have to use. And I have to manipulate for VF. So what do I move first? Time. Okay, so I multiply both sides by time. Time comes over here. All right, then I've got to move VI. How do I move VI? Add. Okay, so now I'm solving for VF. So VF will be 4.5, okay, positive 4.5, plus 3.5 seconds, okay, times negative 2.1 meters per second squared. Right, so when I punch that into my calculator, I got to make sure I keep all of that in there. So 4.5 is positive, 3.5 is scalar because it's time, okay, acceleration is vector, and it's down the hill, which is negative. All right, so I get that my velocity after 3.5 seconds is 2.85 meters per second downhill. Yeah, okay, I have to again match what my vectors in the question were. Okay, now, within the context of the question, does it make sense that this ball would be rolling downhill after a few seconds? Right? I mean, if you just roll something up a hill and then stand back and watch it, yeah, it's going to come back, unless it goes off over the top. Okay, it didn't say anything about that here, so it's definitely got to be coming back down the hill towards us. Okay, so that answer makes sense. Now, here's something that's super nitpicky, but also super important. Are these two vectors the same? Are down and downhill the same direction? They're not. That's going to seem like super anal. It is. Okay, like it just is. There's no arguing that. But it's also true. Down is straight down. Okay, downhill is down a hill. That's at an angle. Okay, they are two different things. Okay, everyone follow me on that?
What is negative for the answer?
No, we don't want to put negative in because we didn't get negative in the question. We got down the hill and up the hill. So your vector at the end has to match what the question gave you. Okay, this happens to my physics guys all the time when we're doing inclined planes. At the end, they'll do the whole thing right, in the end, they'll write down, or they'll write negative, and I'll be like, it's a ramp. It's not falling through the ramp. Okay, if you say down, you mean it fell through the ramp. Okay, you can only fall down, you can't roll down. Okay, you can roll down a hill. Does that make sense? Okay. If you were still using triangles to manipulate equations, that time has passed. Okay, there is no triangle for this formula. There's an addition and subtraction operation in here. Triangles won't work anymore, so bye-bye. Useless, stupid crutch. Okay, can't use those anymore. Okay, give that one a try. It's similar. Okay, instead of rolling it up a hill, I'm throwing it straight up in the air. Okay. What's the trick to this one? What do I have to remember about gravity? That it acts down. Because I initially throw this thing up. Okay, so it's just like the hill question, except now it's actually up and down instead of up and down the hill. Okay, so we have, okay, an unknown initial velocity. Okay, because it says we throw it up in the air at an unknown velocity. Unknown, 0 is known. Okay, so VI is a question mark. Right? It's in the air for 6.5 seconds. What did they tell me? Okay, its final velocity is 2.4 meters per second down. All right, so 2.4 meters per second down, and now I'm going to do this. Positive, negative. Okay, just so I remember, up is positive, down is negative. Okay, and acceleration due to gravity is negative 9.81. Sorry, 9.81 meters per second squared, also down. Okay, if I don't make gravity negative, this ends up being pretty weird. Agreed? Like I get a strange answer. Right. So I got to solve for VI. So A equals VF minus VI over T. And multiply both sides by T. Add VI to both sides. Okay, and then subtract T times A. Okay, and I'm left with VI. All right, so VI then will equal, okay, VF, which was negative 2.4, minus 6.5 seconds, times negative 9.81. So what happens when I subtract the negative? It's like adding, yeah. That way I'm going to get a big positive number here for VI, which fits, right? If I get a negative number when I do this, I did something wrong. The question told me I threw it up in the air. If I get a negative number, it means I threw it down, right? So it's kind of one of those ways you can check if you did something right. Your answer needs to make sense within the context of the question. All right, so when we punch in our numbers here, negative 2.4 minus 6.5 times negative 9.81. Okay, I don't know who threw this, but they should join the major leagues, because that is about twice as fast as a normal person or even a major league pitcher could throw something. Okay? But 100 miles an hour is reasonable for a major league pitcher to throw a really, really fast ball. That's way more than that. Okay? Like way, way, way more than that. Right? So 61 meters per second up. Is the up important? Are the units important? Yeah. Okay. All right, questions on how that works? Everyone's good with that? All right. Give you a 5-minute break here and then we're going to work on something without my guidance and see how you do. Okay, let's have you try this one. So what I'm doing with these questions, I know it seems like, oh man, we just keep doing the same thing. I know how to solve for VF. I know how to solve for VI. Yes, you do. What I'm doing here is changing the context of the question to be less forthcoming about what it's giving you. Okay, I'm making the wording a little more open to interpretation, let's say. Okay, so you get the hang of how to read a question and go, oh, that was VI I got there, and that was VF, and so on. Or, oh, that was forwards and that was backwards, and I got to keep that in mind. Okay, that's where the difficulty comes in. It's not usually the math that trips people up on these kind of questions. It's usually the context of the question. Okay. All right, so this plane is landing on a runway at a velocity of 200 meters per second. What do they give us there? That's the initial velocity. That's kind of where this thing starts. From the context of the question, okay, it's asking, what's the final velocity of the plane? Well, if they're asking what the final is, the other speed they give me has got to be the initial. Okay, so there's all those little tricks to interpreting the question. Do you have a question? Okay, so we know that VI is 200 meters per second. Okay, over a 15-second interval, what did they give me there? Time. Okay, it slows at 6.5 meters per second squared. What did they give me there? Acceleration. And I can really only tell that from the units and maybe saying it slows at a rate. Like this is a rate they're giving me. Okay, so yeah, what do I need to make sure I do with that 6.5? Because it's slowing. It's negative. Yeah, when you slow, your acceleration is backwards. All right, so that's the trick to this question. Okay, the context trick. Slowing means the acceleration is opposite the velocity. Okay, because if you don't do this negative, you get VF to be bigger. I have never seen a plane that lands on a runway and then speeds up. Okay, that's generally bad. All right, so we got that we're looking for, okay, VF. So we got A equals VF minus VI over T. So we multiply both sides by t and add VI. That'll give us VF. And then we just plug in our numbers. So 200 times 15 times negative 6.5. Okay, and that's the key part, is having that 6.5 actually be negative. All right, so then after 15 seconds, it will be moving at 102.5 meters per second. And that will be positive. Right. They don't give me anything else in the question. I could probably say forward, and that would also be correct. Okay, but I would say in this case, you could just write positive and that would be okay. It was really all you were given. All right, does that one make a bit of sense? Okay, but it's tricky, right? If we're not paying attention, really paying attention when we read the question, we can miss a key detail like, oh, that was supposed to be negative or whatever, right? There's those little things that we have to watch for. Okay, this one's tricky as well. This is another context question, and it seems like it doesn't give you anything except one thing, okay? But it actually gives you 3 things. Give you a few minutes to see if you can figure out what the 3 things it gives you. One is right there, one number is right there, but it actually gives you 2 other numbers. Okay, what are the tricks to this question?
It's asking how long, so it's asking the time.
Okay, it's asking for time. How long did it fall for? What did it give me?
The acceleration,
Okay, what's the acceleration?
42 meters per second.
Okay, that would be our, actually that's our final velocity because it reaches a speed of 42. Okay.
All that.
Okay, no, that's okay. So that's one of the things it gives us is VF, okay? Tells us that's 42 meters per second. Which direction would that be? Down, yeah. Okay,
The rock wasn't falling before, so it's starting in the resting position.
exactly. There's a trick to this question. The rock wasn't moving before it fell. Okay, if something falls, I want to use my pen because it'll break. Okay, if something falls, okay, it's not moving the instant it's falling, right? It's not until it's, now it's moving. Okay, so anytime something is dropped or falls, okay, its initial velocity is 0. If it's not 0, it'll specify it was thrown or it was doing this at the beginning. Okay, if it doesn't say that, we assume that it wasn't moving. All right, there's one more piece of information here.
Acceleration,
Yeah, what is it?
9.8 meters per second.
Right. Okay. This is the acceleration due to gravity on Earth. And unless you're told otherwise, you assume all these questions occur here on Earth, where gravity is 9.81 meters per second squared down. Okay? Now, in this question, A is down, VF is down, and VI is 0. Is this thing changing direction at all? So can I make down positive? I can. Or I can make down negative. It'll work out. Okay? I'll still get a positive number for time. You know you've done something wrong if when you're solving for time, you get a negative number. Time can never be negative. What does that mean if you do? Then you went back in time, which means you did something wrong. Okay? Or right, if you were trying to go back in time. But okay, since we're generally not trying to do that, okay, it generally means you did something wrong. All right, so we got these things here. A equals VF minus VI over T. So we've got 42 meters per second down minus 0 meters per second down. Okay, oh, sorry, and we're solving for T, so we got to do this. Divided by 9.81 meters per second squared down. Everything's down, so it's all positive. Okay. All right. gonna take it 4.3 seconds to do that. Okay, is that all right with everybody? Okay, so it's a tricky question, right? Because it's a context thing. Oh, not meters per second, seconds. Okay, there's some times where I have to really read into a question, right? But know that if a question says or is talking about an object caught in Earth's gravitational field, so if it's moving up or down, okay, vertically, up or down, or it's falling, the acceleration is 9.81 meters per second squared. Okay, that's what gravity can do. Does it matter what it is? Do all things accelerate at 9.81 meters per second squared? In an ideal physical world, yes. In the real world, no. Why? Drag, yeah. I mean, if I drop a bowling ball on a feather, okay, the feather does not accelerate at 9.81 meters per second squared. It goes like this, right? Okay, because the air catches in the feather, which is exactly what feathers evolved to do. Okay, that's why birds can use them to fly, right? It won't accelerate. But if I put it in a vacuum chamber and I drop a bowling ball on a feather, they fall at the same rate. Like exactly the same rate. I'll prove it to you. Okay, so you got a race car, reaches a velocity of 80 meters per second after accelerating at 4.5 meters per second squared, okay, for 12 seconds. What was its initial velocity? And we will add to this that those two numbers are positive. Okay, so like I said, this one's a bit easier because there's no contextual tricks to it. It's all just forward, okay? So it reaches a velocity of positive 80 meters per second. If it reaches that, that's not what it started at, that's what it finished at. Okay, so positive 80 meters per second is our final velocity. It did that after accelerating at 4.5 meters per second squared for 12 seconds. Okay, what was its initial velocity? Right? And sometimes you get them and they're this easy. Like I would give you one like this on a quiz. It's not really like a super tricky context question. Okay. All right, so we got to solve for VI. So we got A equals VI, not plus, minus, start that over again. VF minus VI over T. Multiply both sides by T, okay? Add VI to both sides, okay? Then subtract T times A from both sides. So we got VI equals VF minus T times A. So 80 minus 12 times 4.5. Okay, everything is positive, so I don't have to worry about any of that. Right, so 80 minus 12 times 4.5. All right, so we're looking at an initial velocity of 26, positive 26 meters per second. Okay, how are we feeling about these? Okay, like is the algebra okay? Everyone's good with the manipulating the equation? Okay, because the context of the questions is going to get increasingly more challenging. Okay, so it's just going to be about being able to read them and get what you need from them. Okay. Like this one.